So now from the chapter number 5 differentiation, today's in part 2 we are completing derivatives of inverse trigonometric functions and some complicated questions where we have to use logarithms. So these are the two topics. So first we are starting with the inverse trigonometric functions, which we have already completed in chapter number 2. Suppose we have y equals to sine inverse x is a function and we want to calculate the derivative of sine inverse x. So this we can write as sine x in terms of sine y equals to x. So we can differentiate now with respect to y, dx by dy, this will become cos y. Don't multiply dy by dx because we are here differentiating with respect to y. That's why dx by dy is cos y. Now, if I want to calculate dy by dx, I have to write 1 upon cos y. But again, I want to converting cos y to sin y. So applying class 10th identity, what we can write? Dy by dx. And what is sin y? Sin y is nothing but x. So d by dx of sine inverse x is nothing but 1 upon under root 1 minus x square. Is the formula for differentiation of sine inverse x. Similarly, we can calculate for y equals to say tan inverse x. Tan y equals to x. Again differentiating with respect to y. So what we are getting, tan y differentiation sec square y, and here dx by dy. But we want to calculate dy by dx. So dy by dx equals to 1 upon sec square y. But you know the value of tan y. Again applying class 10th identity. Sec square means 1 plus tan square. What is tan y? You know x. So d by dx of tan inverse x, d by dx of tan inverse x, 1 upon 1 plus x square. D by dx of sine inverse x, 1 upon root 1 minus x square. Similarly, we can derive for other four. Y equal to cos inverse x, y equals to cot inverse x, y equal to sec inverse x, y equal to cosec inverse x. The important point is, just for fun, whenever the trigonometric function starts with the alphabet C, answers are negative. Either it is simple differentiation or it is inverse differentiation. For example, suppose I want to calculate d by dx of cos inverse x, then simply you have to put here minus. Correct? Suppose I want to calculate d by dx of cot inverse x, simply you have to put here minus. Correct? And the last one, a pair of sec and cosec. Y equals to, if sec inverse x and y equals to say cosec inverse x, then a small change, dy by dx equals to 1 upon x under root x square minus 1, where this x is modulus. Similarly, dy by dx of cos sec, simply put minus and you can derive it very well. So these are the 6 inverse trigonometric functions. Their derivatives are as follows. Now, applying class 12th, chapter number 2, knowledge of inverse trigonometry, we can calculate the derivatives and using these 6 formulae. So first we start from exercise number the same 5.5. Write down first question 5.3. Exercise 5.3. Say sum number 10 to 15. So sum number 10. Y equals to tan inverse 3x minus x square divided by, where is in the proper range, x less than 1 by root 3 and minus 1 by root 3 is the. Now, as we have completed class 11 formula of 10, because tan inverse is outside. So if we put x equals to tan theta, put x equals to tan theta, what we are getting, y equals to tan inverse 3 tan theta tan square theta 1 minus 3 tan square theta. Formula question, please check it. Now, is a class 11 formula tan 3 theta formula. So simply we can write tan inverse tan 3 theta. This 3 theta is lying in the proper range. So these two neutralize, y equals to 3 theta. So 3 is as it is, and what is theta? Tan inverse x. So is a just recap of our inverse trigonometric topic. Nothing is new. We are solving just like inverse trigonometric simplest form. One step is extra. Now we want to calculate dy by dx. 3 constant d by dx of tan inverse x. Now you know the formula. Answer. Correct? One more. Say sum number 12th. 11th and 12th similar questions. So we are taking 12th. Y equals to sine inverse 1 minus x square upon 1 plus x square. 0 less than x less than 1. Again, some formula in terms of 1 minus square upon 1 plus x square or 1 plus upon 1 minus. You know very well. If you put x equals to tan theta, what we are getting? Y equals to sine inverse 1 minus tan square theta upon 1 plus tan square theta. And you know the formula from class 11th. Y equals to sine inverse is nothing but cos 2 theta. Yes or no? Correct. But this cos we can't utilize with sine inverse. That's why you have to change in complementary angle system sine 90 minus 2 theta. Now sine inverse neutralize. Answer is pi by 2 minus 2 theta. This is only the simplest form. Just like question of inverse trigonometry, simplest form. Up to this step, no problem. Now one step is extra. You have to differentiate the last line. So dy by dx, for the constant, you know derivative is 0. And we have just completed the formula for d by dx of tan inverse x. 1 upon 1 plus x square is the answer. Simple. Okay. Next is sum number 15. Y equals to sec inverse 1 upon 2x square minus 1, where the range is given to you. Now tell me what we can put here so that it will become a formula of cos 2 theta. Here y equals to sec inverse. We can write 2 cos square theta minus 1. So here we are substituting x equals to cos theta. Why? The reason is very clear. Here it is sec, and this sec, if it will become some quantity of sec. So this will be a formula 1 upon, cos 2 theta. Sec inverse cos 2 theta in the denominator we can write as sec 2 theta numerator. Sec and sec inverse neutralize. Answer is only 2 theta. This means 2. What is theta? Cos inverse x. This portion is revision of, again I am saying, is a revision of inverse trigonometry chapter number 2. If you have not completed, please go through our previous videos of inverse trigonometry. Then only you can solve up to this part. The last part, dy by dx. 2 constant, and derivative of this one is nothing but 1 minus x square inside the root is the answer. So I think the inverse trigonometric questions, derivatives of inverse trigonometric questions are very easy and you can solve it in this manner. Correct? Now the next concept comes logarithmic differentiation. What is logarithm? First time you heard this name, logarithms. So many calculations in physics practicals, chemistry practicals. Science students are already using logarithms. But for the commerce students, it's a new concept. What is log? Suppose we have 2 to power 3 and what we are saying in indices, 2 to power 3 is 8. This is the indices form. If I want to convert it into log, then log base equals to 2, value of 8 is said to be its power, indices, power 3. Indices we can converting into log. The log function is just like, if you see the graph on your Ncert page number 172, graph goes like this. This point is 1, 0. We are getting the range as all real numbers, but we are substituting the value only positive. Only positive real numbers as a domain, but range is all real numbers. When we are here at 1, 1, 1, 0, if we put log 1, we are considering only natural log. But if it is base 10 and value of 10, it will be 1. So graph is increasing for the values when we go above 1. But when we are taking less than 1, but not negative numbers, we are getting the values in the 4th quadrant. But it will never touch the y-axis. Is the graph of log x. Now the rules of log, the first one is log, say base a, b into c. Product of two numbers, because the complicated cases of the derivatives we have to take log. That's why the logarithm concept is very important. So whenever the product of the two functions, we have to write log b plus log c. It means the product is changed into the sum of two logs. Similarly, if the second one, log a, by the way it is b by c, then in this case log a, b minus log a, c will be the formula for subtraction. It means if it is division, we have to change into subtraction. The next one is log a, b to power c, b raised to power c. It will be c comes forward and log ab remain as it is. Correct? So this is the formula number 3rd. Now 4th. Suppose we have base of a, but since we are treating only the derivatives when nothing is given, it means log base e is given, and it is said to be natural log. In some books they will write only ln. Ln means base e. Correct? But if they write log something with other base, then they write the particular number a, b, 10, 8, 2, 3, whatever. But when nothing is given, it means it is clear that it is only natural base log E. Correct? Now, log AB, but I want to convert it into log base E, because we have the formula of log x, derivative of log x base E is 1 by x. Correct? So we have to convert this log base A into base E. Then how we write? First we write the base E and base E in the numerator and denominator. The upper quantity remain in upper part and lower quantity remain in lower part. The best to learn this formula, once again, log base A and B, we want to convert in any other base. Here I am converting in base E. Then first we write log base E, log base E. Upper portion, value on upper, and lower portion on the lower. Base changing formula. It is said to be base changing formula. Sorry. Now, the next one is, whenever, something to power 0 is what? 1. 5 to power 0 is what? 1. 11 to power 0 is what? 1. So, if you take log of this one, what will get? Base 2, value of 1. Answer is 0. So, whatever be the base, the log value 1 is 0. See, whatever be the value, base of value 2, 3, 4, 5, 10, 11, E, whatever. But if you want to calculate the log value of 1, its value is always 0. The reason is very simple. Any number to indices power 0, 5 to power 0, we are getting 1. The same thing, suppose we have to put 2 to power 1. What you are getting? 2 to power 1 is 2, 3 to power 1 is 3, 5 to power 1 is 5. So if we take log base 2, value 2, what we are getting? Power. So very important formula, log base and value same, then directly we can write 1. For example, here what we write? Log base 10, value 10 is always 1. So it is true for all. By the way, it is A and A, 1. E and E, 1. And whenever log of value 1, the answer is 0. So these are the 5-6 important forms. But one more important form which we can use in some questions, especially in competitive exams and differential equations. One important concept. What important concept? That suppose we have e to the power log x. Suppose it is 1. Very important concept we are using in this chapter differential equations and some problems in this next exercise also. So what is the importance of this one? E to the power log x. If we take log both the side, see what will log e to the power log x. And what was the formula? Whenever powers are there, powers come forward. So this will convert log x, log e. And when nothing is there, it means base is always e. So this quantity becomes 1. Answer is log y equals to log x. Hence, y equals to x. The most important article for many questions. So listen, once again, e to the power something with log some positive, this y is positive quantity. In this case, y equals to remain x. For example, y equals to e to the power log sin x. Now tell me, what will be the answer? Correct, sin x. One more, y equals to e to the power log x square. Answer is x square. Y equals to log x root x. Answer is root x. Write it correctly again. E log root x. So this form we can apply many times. So now we start problems based on logarithmic differentiation. is our next topic, logarithmic differentiation. Whenever we have complicated functions, powers are very complicated, cube root, 2 by 3, 5 by 3, so many functions in product or some functions in division, then the shortest method is taking log. For example, suppose a question is y equals to x to power sin x is a complicated function. We can't use chain rule, we can't use implicit function. Power to power, these type of questions will make very easy if we take log, because we have the log properties. Taking log, both the side. What was the property? Whenever it is power, power comes forward. So here sin x log x. Now it is nothing but class 11th question, u and v, product rule. So now differentiating with respect to x. Log y is a function of y. Last topic, implicit. Log y derivative is 1 upon y dy by dx. Now product, sin x silent, d by dx of log x silent, d by dx of sin x. So 1 upon y dy by dx, sin x constant, d by dx of log x, you know, 1 upon x, log x as it is, and d by dx of sin x, you know, cos x. But our aim is to calculate dy by dx. So dy by dx equals to y sin x upon x and log x cos x. What is y? Y means question. So here the last step, you can substitute the value of y and get the final answer, log x cos x. Simple. Once again repeat it. Y equals to x to power sin x. Complicated question, and for complicated question we have log. So taking log both the side, log y equals to property of log, power comes forward, so sin x log x. Now differentiating with respect to x, parametric, implicit, 1 upon y dy by dx equals to sin x constant, d by dx of log x constant, d by dx of sin x. 11th class product rule. 1 upon y dy by dx equals to sin x log x derivative 1 by x plus log x derivative of sin x is cos x. The last step, since y is here in the denominator, to the numerator. Y meaning means question, answer. Simple. Now suppose two questions in the addition form. The same sum but with complicated. We'll make cos x to power sin x. Now what we'll do? Three important wickets of the cricket. You know, off stump, middle stump and leg stump. This type of questions, what I say is a off stump of class 12th. Three important stumps, three important portions where students do commit mistakes is the first type question. What the students say that they are taking log, first step, they are taking log, and they will get big 0 for the first step. Why? Because we can't take log in addition and subtraction form. If it is multiplication, we can convert it into addition. If it is division, we can convert it into subtraction. But already it is in the plus and minus. We can't take log. Is the off stump of class 12th mathematics. You have to make this one as u and this one as v. These are two separate questions. Now u equals to x to power sin x. Solve completely as we completed the last question. Separately solve v equals to cos x to power sin x. Correct? And then add final answer, you will get full marks. But if you start with the first step taking log, you will get the answer. But actually the first step is wrong. If it is in the product, we can take log, no problem in the first step. But if you hear it is plus or minus, we can't take log. Very, very important. Put a red line mark for these type of questions. But alternate method for the competitive exams. If we want to solve directly, we'll use the last property of the log. Somebody wants to use that property without taking u and v, then we can solve, no problem. We can write it as log to power. We can write like this, y equals to e to the power log x sin x, and this we can write as e to the power log cos x sin x. Why? The reason is very simple. You can quote it because e to the power log p is nothing but p. This concept you have to write in CBSE. Then only you can start with this method. In competitive exam it's okay, no problem. But since this method is not given in our Ncert book, you have to quote the formula. We know that e to the power log p equals to p. That's why we are using it. So here some function is suppose p. This is our p. We can write e to the power log p. This function is suppose p. We can write e to the power log p. So now the next step, e to the power sin x log x and e to the power sin x log cos x. Yes or no? Now dy by dx equals to, apply 5.2 exercise chain rule, function of a function. E to the power something, first step, e to the power something means e to the power something. What is something? Product rule, sin x constant, derivative of log x constant, derivative of sin x. E to the power t, derivative of t, product rule. Second part, e to the power u, and the derivative of u, sin x constant, derivative of log something means 1 upon something, and something means minus sin x, plus log cos x silent, and derivative of sin x is cos x. If you solve in this way, then your answer is correct. Then no need to take u and v. It's actually easy method, but you have to clear the concept that we are using e to the power log p means p. So once again, since it is important, an alternate method, we'll revise it once again. Y equals to x to power sin x and x plus cos x to power sin x. We can't take log here directly because here the plus sign between the two functions. If it is product, we can take log. But if it is plus and minus, we can't take log. That's why we have two methods. Either you put this one u and this one v and separately solve the two questions and then that. Alternate method is y equals to e to the power log, put the function, e to the power log, put the function. Logarithm rule is whenever it is power, power comes forward, no problem. This question separately become a question of the chain rule. Yes, this question is a separately question of the chain rule, and directly you will get the answer. Actually this one is a time saving, no doubt, but if you have the concept. Correct? Good. Now few problems from your Ncert exercise number 5.5. Note down exercise 5.5. First question 5.5, y equals to cos x, cos 2x, cos 3x. Since question is complicated, lengthy, we can solve by product rule, no problem. We have three functions. But to make it easy, our calculation work, we are taking log. both the side. Log y equals to log cos x, log cos 2x, log cos 3x. Why? Because these are in the product form, and whenever we take the product in the product, it will convert it into addition. Now differentiating with respect to x. Log y means 1 upon y. Since it is a function of y, you have to put dy by dx like implicit. Log cos x means 1 upon cos x, chain rule, and derivative of cos x minus sin x. Similarly, log u, 1 upon u, derivative minus sin 2x, and for 2x, 2, chain rule, plus log something, 1 upon something, for this one, minus sin 3x, for 3x, into 3. Our aim is to calculate dy by dx only. So dy by dx, y goes to upper corner. Y means quotient, cos x, cos 2x, cos 3x, and inside whatever you want to write, the complete, all the three functions you have to put here. And is the answer. Clear? So whenever the completed questions, we have to use log. Few more questions. Question number 2. Under root of x minus 1, x minus 2, x minus 3, x minus 4, x minus 5. No hint is required because it's clear it is very complicated question. We have to apply only the log, no other option. Otherwise it will become very lengthy. So taking log both the side, log y equals to, power is half. So we can write half log x minus 1, product half log x minus 2, division half log x minus 3, division half log x minus 4, division half log x minus 5. So whenever it is division, you have to put minus minus minus. Whenever it is product, plus plus plus. Now is a question of the first exercise. Very simple question. Differentiating with respect to x, 1 upon 2 log something, half log something, half log something, half log something, and the last. Every time the formula derivative of log x is 1 upon x, derivative of log x is 1 upon x, derivative of log x is 1 upon x. Our aim is to calculate only and only dy by dx. Hence y means quotient, and then you have to put all the answers inside the bracket. And here it is the question: x minus 1, x minus 2, x minus 3, x minus 4, and x minus 5. I think the log concept is clear. You can solve exercise number 5.5, but be cautious for the question number 6, 7, 8, 9, and 10 and 11. Why? The reason is very clear. We can't take log in addition and subtraction form. One more important question after that particular type of questions. Say from question number 12 to 15, where we have to use implicit as well as log. Say cos x whole power y, cos x whole power y equals to cos y whole power x. Taking log both the side, y log cos x log cos y. No problem up to this step. Differentiating y silent 1 upon x, log x silent derivative of y, implicit type. X silent log something means 1 upon something, for something minus sin y, and since it is y, dy by dx. x silent. Next time, log cos y silent and derivative of x. Listen again once. Okay. Y log x derivative 1 upon x plus log x silent derivative of y dy by dx equals to, these are the two functions, x silent derivative of log t 1 upon t, what we assume t, minus sin y, since it is y, implicit function dy by dx, and log cos y silent. Our aim is to calculate dy by dx. So dy by dx on one side, dy by dx on one side, and remaining on other side, dy by dx functions on left side rather than dy by dx on right side. Dy by dx equals to, last step for you, log cos y minus y by x upon log x sin y divided by cos y is the answer. You can simplify and get the final result. Correct? These type of questions, homework for you 12, 13, 15. Similar question 12, 13 and 15 for your homework. कर लेंगे ना? ओके. सो ये हमारी बात हुई, डिफरेंशियल में हम आगे बढ़ रहे हैं. कहां तक पहुंच गए? 5th एक्सरसाइज आपने कंप्लीट कर ली है. नाउ इज अप टू यू, आप कितनी मेहनत करते हैं, कितने अच्छे से डिफरेंशियल करते हैं. क्योंकि डिफरेंशियल कैलकुलस अगर आपको अच्छी आएगी, देन ओनली यू कैन गो फॉर इंटीग्रल कैलकुलस. And differential calculus and integral calculus total combined 35 marks out of 80 in CBSE syllabus 2021. 35 marks. So I think you can do it very nicely. तब तक प्रैक्टिस करते रहिए, और अगर अपना लेक्चर पसंद आ रहा है तो गुरु दक्षिणा में लाइक. गुड बाय.